2 million people in the United States live with an amputation, most of which are of the lower leg. After an amputation, the patient will rely on a prosthesis to regain the ability to walk. However, currently there are 3 problems when walking with a prosthesis. First of all, it takes up to 30% more energy, which reduces participation in society and mobility. Also, when someone loses their foot, they also lose the sensors in their foot, and this reduces stability. And finally, people report pain in the knee and the hip of their healthy leg and also in their backs. And this is due to the higher forces that are present in the healthy leg. Currently, a prosthesis is prescribed based on the activity level, and the effect of the prosthesis on the gait of the patient is actually unknown. And this is different from other fields in engineering, where often a device is simulated to evaluate its performance before it is actually used. I would like to do this as well with prosthesis. So I am creating a tool that engineers can use to evaluate a prosthesis before it is even worn by a patient. So this tool should allow the engineer to look inside the body to see what forces are higher, for example, and which muscles expend more energy, such that the engineer can make the necessary adjustments to avoid any issues from even happening. This tool is called predictive simulation. A predictive simulation is a computer simulation that predicts how someone walks based on their height, their weight, and the type of prosthesis that they use. And it has the ability to look inside the patient. And I've already created a simulation with a very simple prosthesis, and I found something surprising. Because even with a simple prosthesis, it was possible to reduce the forces in the healthy leg by walking slightly differently. This means that we can train a patient to walk with the gait I discovered, such that they already reduce the pain that they report right now. So next, I've also implemented a method to look at stability and energy efficiency. So I've included uncertainty in the environment, such as an uneven floor, so that the engineer can see how the patient and their prosthesis responds to a disturbance. Also, I've implemented a method to look at energy efficiency. So to do that, I ran an experiment and measured how much energy people expend when they walk, and I selected a model that calculates this as accurately as possible. So with this tool, I've already shown that patients can walk with lower forces in their legs and reduce some pain by selecting a specific gait. Also, I've implemented methods such that engineers can evaluate the energy efficiency and the stability of a prosthesis. And hopefully with these tools, a prosthesis can be designed with which these 2 million people that live with an amputation can walk as safely, as pain-free, and as energy efficiently as any one of us.